explain. This is actually somehow we are not announced that one. Different teachers will taught the linear algebra. Okay, it's depend on.
Okay, sir.
So let us start probability.
Yes, sir. Sure.
Sir, could you off the video, sir? Turn off the video.
Turn off my video.
Yes, sir.
Yes,
Internet.
sir. Internet issues coming,
Acha,
sir.
due to internet issue, that's fine. There is no issue. I can off it. That's fine.
You can also
I'm,
turn it off.
you can turn off also from your side.
Turn
Also,
off
I know.
incoming video. You can
Okay,
option.
no issue. I'm turning off starting point, so that's why I have opened my camera. From my, it is better from my side also, because sometimes camera is gives takes the huge data, and it is internet issue. So okay, I'm turning off the camera, microphone, and I am just please be organized. My suggestion. Don't chaos. If you chaos, then I am forced to your microphone off. Okay, but I am not off your microphone. So please turn off your microphone. If necessary, then you turn on and talk with me. Okay. And my assumption is that you all know about the probability theory. That is how, and everywhere we have used, because you see the playing, that means cricket play or football, whatever you are watching in TV, you are saying that this team will win, that team will win. So how do you guess it? So this guess actually the probability. You are applying in background, the mathematics background. Mathematics is probability theory. So that's we are going to discuss. And I know you all have learned in class 10+2 this probability theory little bit, and that in your syllabus also there is no more about the first part. First part is the axiomatic definition, and two definitions I am going to give. Some terminology you know, laplace or sample you know, and event. This term you need to familiar, but my assumption again you know these terms. Using that, we need to solve some problems. And this type of problems you already solved. But still, since in your syllabus today, at least first class, I am going to give again. Maybe some students are facing that it is I am repeating. So it may be repeat from or some if you see that this is new, then it is fine. But all students should follow me. Whatever I am going to discuss it. So let us start the definition. Probability theory, I am writing like this, MA02, MSc02, probability 1. And as just previous semester, MSc01, I'll give the whole written part. So everything you are getting the ready-made, and end of the class, later on, I am just sharing this my PDF copy, whatever we are going to discuss today. And whatever we are going to discuss in the remaining, my target is within 5 class, I'll finish this probability theory, whatever in your syllabus. My target is like this. And whatever I am going to give, going to discuss, everything I am giving to you as a PDF file. So you may read it, and it has actually 33 problems. So my suggestion is that you should try to solve these 33 problems yourself with the help of your friends positively. So let we define the first is the definition is relative frequency. So something will relative frequency. You know that this suppose that the experiment actually, because we are talking about that starting of the play, that means for football or cricket, we are just guessing this team will win. End of the play, we are able to understand that okay, this players won this match, and your guess is correct or not, you can see later on. So somehow we are doing some mathematical way, and we need our trend to positive way. That means in somehow the logical way. So an experiment, that means we are trying to see, we are doing some experiment. That means you are saying that the one thing is that suppose You are saying that this team will win. That is actually you are talking about the previous some experience. That means you have seen a few plays. That means maybe they are played 10 times before and you have seen that and their quality and their activity and the opponent also. That means opponent, you know that they may be weak or not. It is actually the previous experience. So that the way to guess it, and this guess actually we are going to term is probability. So that experience actually we are saying that experiment, mathematical term. We are whatever we have experienced due to our experiment. So suppose that the random experiment is repeated n times. So whatever I gave just 10 times, we are taking in mathematical, it is n times. So any experiment we have done the n times. And suppose any event, that means, for example, win of this team. Any events we are denoting by A. This event A occurs in A times. That means suppose you have seen the playing of a particular team 10 times and you have seen that this team won only 3 times. So this NA is that 3. So and the n is that n equal to 10 for this particular event. So this is the way of the definition. And suppose, so I repeat this, suppose the random experiment is repeated n times. If the event A occurs n times, then the probability of the event A, the probability of the event A is defined as like this. Defined is P of A, probability of A, the event A is equal to taken the occurrence in A, number of occurrence divided by the total experiment divided by n. And if we take, so if we take this somehow more times, that means suppose the last 10 playing you have seen, if you see it is 100, then you can go more accuracy. So that's why we are taking like this limit n tends to infinity. That means you are taking as large as possible of n. Then this value somehow, and if this series, that means this n going to infinite, and if it is converse, then that value we are taking the as a probability of A. But sometimes this as a limit may not be converse. So because it is not always the smoothness is smooth, whatever you have seen is the series or sequence, that is not the smooth way, it may be random somehow. So it may not be the converse, but somehow with when we are taking the n is very large, then we can take somehow this value is some finite value, we can consider this one. So this is the definition. For example, particularly suppose we are generally any book, anywhere or any teacher teaching you, so this type of example we are taking the playing card. Are you familiar with card? In Bengal it is tash.
Of course,
And
sir. Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
and
Yes, sir. 52.
so
52.
many people, so many people playing card. There is
52, 13, 4.
spending time and enjoying also. And another is,
Yes, sir.
huh?
Yes, sir. Sir, Ayan is expert, sir.
Oh, very good. I am also. No, I don't know I am expert or not, but I play good, I think. Okay.
Okay.
Because in my post graduation in university there was a competition. I was the first position. Card playing. Anyway,
Yes,
that's
a match of cards, sir.
and some people know breeze. Can you play breeze? National breeze, whatever you know. National breeze playing in
I've
the some
heard,
of.
sir.
That's good. Okay. Very good. Okay. And Ludo. And you are familiar with this one mainly. Ludo, at least
Sir,
I
Ludo
hope all
more
students
depends upon luck. But
played this
playing is
Ludo. And the major thing is this one. Somewhere it is written 1, somewhere 2 dots, some another face is 3 dots, and some faces are 4, 5, 6 6 faces. And this is called the dice, D-I-C. This dice. So one thing is that now when we are playing card, so suppose and you know that in playing card it has 52 cards when we are playing, and it has 4 colors, and each color has 13 cards. Now whatever, so those who don't know the cards, 52 cards, suppose 52
Sir,
cards are,
Joker is also.
no, actually Joker is not coming in the picture,
Joker
or
extra.
that is
The
extra,
Joker
that
is
is not
extra.
coming in the play.
The 50, mainly there is 52.
Joker is given due to if we have lost any card, then we fill up that with that Joker. That is giving the 2 or 3 cards extra in a pack. So in pack we always the standard is 52 cards, and these 52 cards, as suppose it is written 1 to 52. And now if we ask, so randomly, suppose it is just shuffled it, and if we choose randomly one card, what is the probability that this card is 1? But anyway, those who don't know the playing card or Ludo, you need to learn, because so many questions always coming due to this card and dice. So
Sir, I don't know the card.
And sir,
but
what questions come in Ludo?
Hmm?
Sir, what questions come in Ludo?
I am coming later on. I given so many questions, 33 questions given. Some questions taken. I am sharing that PDF. Probably today I am sharing. So after sharing, you are getting. Okay, I am coming one by one. So,
Okay, sir.
But you need to little bit idea what is cards. You may see YouTube. So maybe 5 minutes you will spend there. You will see what is card, and or some, your friend will teach you when you are coming in the campus. So card, so by default, you think like this. Suppose we have 52 cards, and this card has written 1 to 52 number. First card is 1, second card is 2, third card is 3, like this. And suppose the question is, if we choose randomly, that means without knowing, without seeing, and just randomly choosing one card, what is the probability that we are getting 1 or we are
1 by
getting 2?
52.
1 by 50.
And similar question, yeah, whatever you have said, that is correct. Similar question, you can, those who know this part, suppose you are throwing one die, and what is the probability that it comes the above part is 1, or
1 by
means
6.
what actually?
1 by
1
6.
by 6.
1 by
You
1 by
all
6.
know 1 by 6. So that type of, that is actually the definition. So this is the definition. We call this definition is relative frequency definition. And from this definition, we can observe something. That means you see, since here NA cannot go, so this NA is always less than or equal to N. That means you are trying N times, you can't get more than N times in your favor, more than N times. So it is always like this. So this implies that NA over N is less than or equal to 1. And you see, since N you are trying, it is positive, any positive number, 1, 2, 3, 4, whatever, any positive number. And in some favorable case coming in your hand, that means NA, this favorable case, NA, and this NA also some integer. So we are dividing some integer by some integer. So that means what we are getting. And this above part is always, that means both are positive. So if we divide any two positive integers, it is always actually greater than or equal to
Rational number.
so yeah, rational number, and my target is actually it is greater than or equal to 0. You see. So the first observation we can see, number 1, is this ratio is lie between 0 and 1.
0 to 1.
0 less than or equal to n. So I hope you got this idea. It is that means, and this, if we whatever we are taking this n tends to infinity or whatever. So this is lie between 0 and 1. So we conclude that the probability of an event A is lie between always 0 and 1. The first thing. So some question we are giving, what is the probability of this event, whatever that. So your answer should be lie between 0 and 1. This answer cannot go more than 1 or some negative. if your answer is coming like that, that means you are doing some mistake. So be careful. That helps this property. And similarly, when it will happen 1, that means you have tried n times and all times your
Yes,
event happened. Then it is actually the above part and below part is going same. That means this ratio is goes to 1. So any experiment always happen in your favor, then it is probability 1. And when does it happen 0? If you are trying n times, never happened, then this probability
Yes.
goes to 0. Okay. I hope you are getting when it is happening 0 and when it is happening 1. And we are actually, I'm giving so many definitions today, and if I get some time later on, I am going to give some examples. If I don't, otherwise I'll continue next class with some examples. That is tomorrow. And now, one definition is mutually exclusive. Two events, suppose A and B. So keep in mind event. I'm using this term always. EVENT, event. You know, I hope. Event means whatever you expected or what is your favorable part, that is actually event. So this in the just previous example, event is NA or event is A. Okay, not A. NA is the number of the happening and A is the event. So here similarly we are taking suppose two events A and B, and we mathematically will say that if they are mutually exclusive, that means what? That means uh,
A intersection be 0.
A is not depend on B or B is not depend on A. So then, or you can say that A can be if A happened, then B cannot be happen, or if B happen, A cannot be happen. Then we call this mutually exclusive. And mathematically, you can say that if A and B are mutually exclusive, then uh, n of A, we can say like this, n of A union B, that means together it is happening is basically n A
plus
plus
Plus and
n
B.
B. Yeah, you know this. Good. And if we divide it by both sides by n is a positive integer, that means number of happenings. And if we take again both side limit n tends to infinity, you see, and n tends to infinity, here we are taking limit n tends to infinity, then according to previous definition, we are getting like this. Probability
Of A union B.
of A union B equal to probability of A plus probability of B. So be clear here. This direct addition we can apply if it is mutually exclusive. So this term be clear. Can you hear me? Is there any buffering online?
No, sir.
No, sir.
No,
okay,
sir.
sir, it's okay, sir.
Okay. Okay. So if mutually exclusive, then we are getting this one. So
Yes, sir,
you
it's
remember. Fine. Now I'm giving another definition. We called it is axiomatic definition. So these two definition you need to learn. So sometimes axiomatic definition you will feel difficult, but after realization it will help you later on. So
Sir,
same probably.
sir,
Yes, please.
sir, can you once again make us understand the meaning of mutually exclusive events?
Acha, 1 minute. So one thing you can say that if we go back way, the probability A and B are two mutually exclusive event if this condition satisfied. Probability of A union B equal to probability of A plus probability of B. This is opposite way I am saying. But directly if you say the mutually exclusive means it one event is not depend on the other. So or you can say that if A happen, B cannot be happen. So for example, you are throwing a die. If top part is 1, 2 cannot be in the top part. At least that event. At least that throwing. Okay, fine.
Yes, sir.
Now, axiomatic definition, we are considering. Suppose S, okay, the sample space. You are familiar with this. Let's say, what is that? We denoted by S. Sample space means the total
number
our
of
knowledge
steps
that
the
means
event happen.
Sir, total number
yeah.
of total number of
What can be happen in the experiment? What is the total output? We can think like this. Okay. And so suppose let S be a finite sample space and A be an event. So we are denoting S be a finite sample space and A be an event. Then in the axiomatic definition, the probability PA of an event A is real number assigned to A which satisfies the 3 conditions. I repeat, let S be a finite sample space and A be an event in S. Then in the axiomatic definition, the probability P of A of the event A is a real number assigned to A which satisfies the following axioms. So axiom 1 is the P of A is greater than or equal to 0. This should be satisfied. Axiom 2, P of S, if we take the whole space, this should be 1. And number 3, these 3 conditions should be satisfied for finite sample space. P of A union B equal to P of A plus P of B if A intersection B equal to P. Means what? That means this A intersection B equal to P means there is no common element or common set. Okay, you are
Mutually exclusive.
so yeah, actually mutually exclusive, exactly. So sample. So if these 3 conditions satisfy, then we denoted by the probability of P of A. So nice thing is that if you think deeply, these 2 definitions are actually equivalent. So sometimes in the whatever in common examples, the first definition is nice for us, and second definition is somehow little bit difficult sometimes, but you can think it is. The first case we already said that any probability should be greater than or equal to 0, and when it happen? P of S equal to 1 if the whole thing we are taking, the event is the whole thing. That's actually, so these 2 condition is actually this this boundary, whatever I have said, this one. And last one is that they are mutually exclusive. If these conditions satisfy, then we say that the event A, the probability of the event A is P of A is that actually, that definition. Okay. Now, and if the one condition is that to define this one, we have taken this sample space is finite, we have considered. But this definition we can give if a sample space S is not finite. So suppose this S is not finite and it is infinite, and it has infinite number of events, A1, A2, dots, infinite sequence of mutually exclusively events in S. That means A1, A2, A3 are all mutually exclusive events, and it is going infinite in S. That means AI, the mathematically you can say that AI intersection AJ is equal to 5 if I not equal to J. Then the number 3, actually instead of these 3 axiom 3, the for infinite case, we can you need to satisfy this one. Probability of union ai equal to 1 to infinity equal to summation over e of ai I equal to 1 to infinity. That means this condition need to satisfy. If this condition satisfied, then we call the probability of A is that value, whatever we are giving the value. Now, we are interested basically in your syllabus or your practical syllabus. If it is this sample space, this S is finite. Generally, we'll take the finite case. Generally, we take finite case and we
can you show the bottom of the page again?
Yes.
Can you show the bottom of the page again for infinite cases?
Which page? Here.
Yes, sir.
Sure, sure.
So if this condition satisfies, then
if this condition satisfies, then we call the probability of A is this. That means here you see that means whatever the values we are defining, that means some values of P, these conditions are satisfied. Some values of that means P of A has some value. We are not clear actually what is that PA. So we can define some PA. This always satisfying. Then if this satisfies, then we call the probability of A is P of A. Okay. Now it is more clear if we consider as the finite case. Suppose suppose sample space S is finite and we are taking like this way, zeta 1, zeta 2, dotted zeta n. Just previous two examples. For card it is 52 and for dice it is 6. So that means what is the output? It can in for card it can output 1 or 2 or 3 like that or 52. In dice it can come 1, 2 or 2, 3, 4, 5 up to 6, not more than that. So this if this type of sample space, finite sample space, and we say that these zeta i's are elementary events, then and let we are considering let P of zeta I equal to Pi. That means, so this Pi we don't know, we will try to find later on. But suppose we are considering that the probability of zeta I is Pi, probability of zeta 1 is P1, probability of zeta 2 is P2. In general, probability of zeta I equal to Pi. Then you see, we already said that so this Pi should lie between 0 and 1. Probability should lie between if it is finite case. And just previous whatever I gave, the summation over of this Pi, if we sum all this Pi, is that means all events, this finite case, I equal to 1 to n, then this is should be 1. That means summation of all probabilities should be 1. And if some space we are taking, that means suppose we are taking a subset, A is a subset of S. That means A has some elements. That means like this, zeta 2, zeta 5, or zeta n minus 1, like this. So these some elements, and this index set, this is another notation actually. This index set, that means 2, 5, n minus 1, we denoted by I, arbitrary index set. So generally we denote by like this. And then we can define this A equal to union of I belongs to index set I, zeta I. So this one we can shortly denote by this. And then the probability of this A, you see, then the probability of A equal to, we can write summation over probability of zeta I belongs to I equal to summation over I belongs to I. So this is actually somehow going more theory part. If some students don't getting it, don't worry, because it is not
Sir.
very difficult and not
Sir,
very
after 2
original.
there is 5.
Huh?
So
Sorry?
A equals to bracket 2. After 2 there is 5.
Oh, yeah, actually I'm written randomly. That means, so here I'm taken A is a subset of S. Yes, I have written it is 5. Okay. So
Oh,
it
okay,
may
sir.
be 3. I am taken just randomly, but some subset. This is example only. Some example which is subset of this S. And S is actually whole this zeta 1, zeta 2, zeta n. Okay.
Sir, what capital I represent?
Yes, sir. What is capital I?
I represent in this case. Yeah, it is. So I know your. So I equal to, it is, you can think like this, 2 for this particular case, 2 5 dotted n minus 1. So some index, that means this mathematical term, some subset of some subset of a index. Index means here in whole index is 1 2 3 4 dotted n. This S equal to, so S equal to zeta 1 zeta 2 zeta n, and index is here, the whole index is 1 2 3 4 5 6 dotted n, and this I, we are taking any subset of that index.
Okay, sir.
Okay, there is
Sir, is zeta also an event? Zeta 1, zeta 2. And A is also event.
when we are defining this probability of A, we need that, exactly correct. That we need, but so that notation we make some feeling easier. That means to write some easier. That's why I have taken. So I is somehow index subset, and we are taking that. So if we know I, then we know A. You see, if we know the index set, what is the subset? From that, just write zeta 2. If you know this I, then you can write directly zeta 2, zeta 5, zeta n minus 1. So these zetas are there, like that way. Anyway, if you feel this part is difficult, you leave it. There is no issue, no effect later on. First time it is, sometimes we feel this difficult, but there is no logical flaw is here. Logically, it is correct. Anyway, so whatever these properties I have given here, number one, you see already, number 1 is this one, number 2 is this one. That means probability lie between 0 and 1, and if we add all probabilities, it should be 1. And if we take any subset of the sample space, then the probability should be the summation of that probabilities. That is, if we find 1 by 1, and if we sum them, then we are getting that the probability of A. That means if A has the finite subset or finite sample space, what is the happening of the all sample space together? If we take that probability, that's probability actually follow the rule for addition. Addition rule follow these probabilities. Okay. And now gradually our target is today is Bayes theorem. So another, okay, particular case here, if the probability is equally likely. So in this case, so suppose we know that this problem equally likely means all the sample spaces and the favorable space, all the space has the same probability. That means, you see, you just previously someone said that the probability of drawing a card is 1 by 52. And if we just change the question, what is the probability to drawing a card number 2? It is again 1 by 52. What is the probability that drawing from a pack of card number 3? So you see here the sample spaces are card number 1, card number 2, card number 3 dotted, card number 50. And all probabilities, that means if we choose any one, it is always the probability is same. So that's we call the equally likely event. That means whatever the event of number 1, and what is the number of 2 and what is the number of 3, all are equal. That is equal, and if we throw a die, It is probability of putting out above. That means we should say that not die. It is unbiased die or real die. You can say that means unbiased die. Then the probability to get 1 is 1 by 6. Probability of getting 2, it is again 1 by 6. So this is actually the equally likely problem. So if the events are equally likely, then we can define like this: probability of zeta of, so we can say that if it is equally, then P1 equal to P2 equal to dot its Pn, and all probabilities are same. So if this one, if this condition satisfied, then we call this is equally likely events. Equally likely events. And so if it is equally like, then anyone, that is probability of for, so if the number of events is n, then P of P1 equal to 1 by n, and this is same as P2, this is same as Pn. So if all are equally likely, then the total number of events, and we define this, the probability is 1 by n, whatever you have given just here. So this equally likely event has the same probabilities, and probabilities is actually 1 by number of events, you can say, number of distinct events. Okay, now we define conditional probability. Oh, I am unable to give examples because we almost, but I should finish the theory part, that means base theorem. Okay, I will not take too much time. So now the conditional probability, suppose a event, conditional probability. In between, just 1 minute, I want to see how many students. Achha, it is 287. I can see so many students not yet joined. That means, or maybe left. Any message? As a something written, I am unable to get it. Probably it is written in Hindi. Like Virat Kohli's probability of getting. Anyway, okay, someone written.
IPL. Yes, sir. Previous month.
IPL.
Sir, absence of
Anyway, I don't use IPL. I don't see IPL or watch IPL.
Virat
So,
Kohli is out of form.
oh, not for yeah. So you are using mathematics. That is the nice thing, and you are learning that one here. Okay. So now the conditional probability. Suppose an event A. What is the probability? That means the conditional probability of an event A is that, given that B is given. So that means what is the probability? So if B happened already, it is given to you. Then you say that what will be happen of A. That we denoted by P of A given by B. That means we say that P of A mod B. Some people say like this, or some people say P of A by B, or it is better. Since you are learner, it is better you say probability of A given that probability of A given B. Shortly, you can say like this. So this equal to the, it is definition, keep in mind. This we denoted by probability of A intersection B over probability of B. So probability of B is given, then this probability. So intersection means, so we are taking the, if they are mutual exclusive, then it, above part will be whatever. Anyway, I am coming just. So I repeat the conditional probability. The conditional probability of an event A is given event B denoted by P of A by B is defined by P of A intersection B over P of B, and it is always true if this is greater than 0. So probability of B should be 0. Otherwise, below will become 0 and it is undefined. So given B should somehow greater than 0. Some probability should be there. And similarly, we can define where this one probability of A union B intersection B, probability of A intersection B means it is joint probability. That means together, what will be happen? What is the probability that together will be happen? Okay, and just oppositely, similarly, we can define. Suppose A is given, what is the probability of B? So just interchanging A and B, we are getting probability of B such that A is given is equal to probability of A intersection B. There is no sense here because A intersection B equal to B intersection A over probability of A. Okay. And in this case, should be probability of A greater than 0. Otherwise, it is invalid definition. Okay. Now, if we simplify these two, you see that means if we take this one just cross multiplication, so first one and second one together, we are getting probability of A intersection B equal to probability of B given A into probability of A. Okay, I've written actually second one first. So multiplying this P of A into P of B by A equal. And this equal to first one, you see, multiplying this one, P of A given B into P of B. So this we can simplify. And so from here, you see, so last two, from these two parts, we can write. Probability. Yes, just 1 minute. I'm coming. Probability of A, I'm taking right side, probability of A given B equal to probability, I'm taking this portion left side, probability of B given A into probability of A divided by, I'm taking this B, probability of B. This is known as base rule. We call this formula we need to remember. So what is the facility here? Suppose we want to find the probability of A given B. If we know the opposite part, sometimes it is easier. Given B, given A, probability of B. We can sometimes it is easy to find and what is the probability of B and what is the probability of B. A. So to find probability of A given B is easier sometimes from right side. So that's why we can remember. And if we interchange A and B, we can get another formula that is similar formula. We called it base rule. BAOI. Oh, we almost time up. Yes, someone wanted to say something. Yes, please.
If if probability of A becomes 0, then
Actually, probably this definition is somehow not defined. Probability of A, that's only what happening. Probability of A. So just coming. Yeah, your question is valid question. This one, you see, probability of A given that probability of B. But if this probability of B is 0, then what is that? So so suppose Virat Kohli will win the match. Given that he is going to the play. So if his playing is 0, that means he is not going to play. What is the probability of winning? It is 0. That means if probability of B is 0, then there is no chance to happen probability of A.
But according to the formula, probability will be infinity.
According to problem?
According to the formula, sir.
The
probability will come infinity.
Yeah, and
No,
probability cannot happen infinity. You see, probability lie between 0 and 1. That's why we are.
Sir, it will become undefined.
Undefined, not infinity, sir. Undefined.
It is better we say undefined. Exactly. It is undefined.
Tending to 0, then it will be infinite.
And you can sense like this way. If A does not happen, then B cannot be happen. Something like this. In this case, actually, if B does not happen, A never happen because B first happen, then A can be happen. So there is no question to define that one. Probability A given that B. Okay, that's why I've taken here probability of B greater than 0. Okay,
Sir,
let us finish. Sure.
Sir,
So
is
I
it
can
same
take.
as relational probability?
Yes, please.
Is it same as relational probability?
I'm not getting your question. Can you please, if it is not quickly relevant, you wait another 2 minutes. I'll take your question. Wait, because I need to finish another one theory part. So after that, I can another. If you have time, I can spend another 15 minutes, whatever your question. And those who are not interested, they can leave also. I'll allow that one. Wait. So everything, whatever I'm writing here, properly written in the assignment, I'm providing you. You can see that one. So last theory is that if this suppose so actually Bayes theorem. So this whatever I given, this is called Bayes rule. Using this Bayes rule or some generalization of this Bayes rule, we called it is Bayes theorem. We are going to discuss that. It will not take too much time. So here let the events A1, A2, dotted AN are mutually exclusive and exhaustive. This is mutually exclusive and exhaustive. That means if you take any two one, that means this two term I should write. You know, Paul, mutually exclusive and exhaustive. The first mutually exclusive means we already said AI intersection AZ equal to P where I not equal to Z. And exclusive means union of this one equal to S, total sample space. So exhaustive means union of I equal to 1 to N is equal to this S. Okay. And suppose let suppose I am saying two things. So let B be any event. That means B is a subset of S. Let B be any event. Event. So that means actually B is some union of AI where I belongs to I, whatever the sample, some subset of AI. Then we can write like this way: probability of B equal to, you see, summation over B intersection AI, I equal to 1 to N. You can write like this. You see, you should write here P of this. Because if you intersection B with AI, it is if AI belongs to B, then it is only AI. If it is AI not belongs to B, then it is 0. It means phi and probability of phi is will take 0. And this equal to, so we can write like this. Are you getting this sense? I hope you are getting. So B is a subset of this, and just directly probability of B without writing like that, we are taking just different intersections with all AI's intersection, and this equal to just Bayes previous theorem, the Bayes rule we can apply like this: I equal to 1 to N. This probably intersection, so you can write probability of B given that AI into probability of AI. Please mute yourself when you need to use you. Okay, we can write like this. Just previous whatever this conditional probability we have written this one from conditional probability. So for this P intersection B, we can write this into this. That's I have written. So this, and you see from here, so we got this one. P of, I'm writing again one line. Probability of, I need to little bit smaller. B equal to last line I'm writing. Summation over I equal to 1 to n. Probability of B given that AI. Probability of AI. Okay. And now just previously I have written base rule. I've just immediately base rule. Where is that? Yeah, this is base rule. So if we take in this case P of if we take A equal to AI, from here we are getting this. I'm just writing here AI such that be given B AI, so AI given like this. That is, instead of A we are writing AI. So we are getting like this. We are getting P of AI given B equal to P of B given AI into P of AI over P of B. And now I'll get, oh, it's better. So, okay, anyway. So I've written that formula this. And so from here, okay, so I'm writing this P of AI given B equal to above part I am writing same P of B given that AI into P of AI, and below P of B is already I have written this one. I am writing this one. Okay. So P of B equal to this one, summation over P of B given AI into P of AI. Summation I equal to 1 to n. I equal to 1 to n. So this formula is actually the base theorem. This one is base theorem. And what is the facilities here? So if the events are finite and they are mutually exclusive and exhaustive, then for finding the conditional probability for any event B given, suppose given probability of AI such that B is given, to find that probability, we can find that since AI are the individual, so if we are able to find the what is AI given, what is the probability of B? If we are, that means opposite direction, from opposite direction, if we are able to find the probabilities, then we can find the correct direction. Then B given AI probability, just sometimes it is easier that AI given B probability of B. So sometimes we will use this base theorem, and hope we will discuss some examples tomorrow. Tomorrow's class is some probabilities example. Okay, any questions? So thank you all. These up to today, up to now.
Sir. Sir,
Yes.
please upload today notes, sir.
Okay.
Yes, sir. Kindly upload this notebook.
I'll upload. So you can see this is in this
Sir,
MS Team. I'll upload. You can collect from there. And
Okay,
whatever
sir,
I have written, I'll also upload regularly. Generally, I'll upload in MS Team. You can find from there. But you see, it is one channel, extra channel I have created, probability channel. There I'll upload. Okay, whatever we are joining here.
Okay, sir.
Okay, so still participants is 255. Okay, anyway, that's good.
Sir?
Stop. I'm stopping recording, and then I'll talk with you.
Take the attendance.